Hey guys, so in this PowerPoint I'm going to be talking about some of the basic geologic structures that you are going to encounter in Lab 9. So let's just hop right into it. So tilted and folded rocks. The Earth is tectonically active, which means that we have tectonic plates moving, and these plates crash into each other a lot. We see them at subduction zones, we see them at convergent plate boundaries, and this can cause stress. So stress is just going to be a kind of force over a set amount of area, and what this can do is it can deform rocks. Alright, so when rocks are deformed, they can either break or they can fold. Alright, so in this lab, we're going to talk primarily about folded rocks. And then in lab 10, we're going to talk about brittle behavior and faults in broken rocks. Okay? So, tilted and folded rocks. So first off, we kind of needed to define deformation. So deformation is a change in shape, volume, orientation, or position of a rock or unit of rocks, or really anything in geology. Anything can be deformed. All right. So put it basically, translation is a change in position. So you're going to take something and move it from point A to point B. All right. The rotation, you're going to change the orientation. So you're going to take a layer or a rock and you're going to tilt it. You're going to rotate it along some sort of axes. All right. So dilation is going to be a change in volume without changing the shape. All right. So you're going to take a square, you're going to make it bigger. It's still a square. The volume is different, but the shape is still the same. All right, and then distortion is you're going to change the shape but not the volume. So say you take a square, you kind of squeeze it into a parallelogram, and it's going to take about the same amount of volume, all right, but the shape is totally different. Okay? So here is a graph of each one of those, and we have the original configuration here. So this is just the original orientation. This is what it was like before anything happened to it. All right, so then here it was taken from here, moved that way. All right, and then here it's been rotated. This one it's been made smaller, and this one it's kind of been shifted over, but the volume is still the same. Okay? All right, so a very common deformation is going to be rotation. Okay? So y'all remember the law of original horizontality. So that means layers are put down horizontal. So that's not what's going on here at all. All right, these layers are definitely not horizontal. So that means they must have been deformed. Okay? So how do you recognize that? Well, on the map, you could just look for any strike and dip symbols whatsoever, or you can follow what's called the rule of V's to kind of get a general idea of what's going on beneath the surface if you have a geologic map. Okay? So when looking at tilted strata or tilted beds, all right, we can tell what's kind of going on just by looking at how the shape of it changes with topography. So on this diagram, we have the orientation of the beds and we have contour maps. All right, and each one of these is slightly different. That's because what's going on with the tilted strata is also slightly different. Okay, so we're going to start with the two extremes. We have a vertical bed, we have a horizontal bed. All right, so vertical beds have no distortion based on the contour lines. All right, so there is no change in the direction or the shape of the outcrop, this shaded in area, based on what's going on with the contour. So we have this valley here, as you can see by the topography here. We have this valley, and this bed is cutting right across it. There's nothing going on that's changing that. All right, but if we look at the opposite, if we look at a horizontal bed, it's following it to a T. Each outcrop contact is on a contour. All right, so it's going to follow that topography. All right, so if you're seeing beds that are following the topography, if they're lining up with contour lines, then you're looking at horizontal bedding. Now what happens if those beds have been tilted? All right, well, if the beds are dipping upstream, all right, what's going to happen is the V point's upstream, all right, and it's going to be very blunt, all right, and then if it's gently downstream, near horizontal, all right, it's going to follow the contours to a point, all right, make a very sharp V, and it's going to have sharper contacts with the contours, all right. Now, if it's dipping steeply downstream, it's just going to point downstream. All right, so in this case, it's going to, as it gets deeper, you're going to see more of it. As it gets deeper, you're going to see less of it. All right, so we've tilted rocks, and now we're going to fold them. So you're probably thinking that rocks are really brittle. How do you take such a brittle material, something that breaks and shatters when you hit it? All right, how are we going to fold that? Well, it's just a simple addition of a overhead confining pressure and a lateral stress. All right, so we're going to take a rock and we're going to squeeze it from up and down. All right, maybe because it's buried beneath kilometers of rock above it. All right, it's not going anywhere up or down. All right, then you're going to slam a continent into it. All right, so that's huge amounts of stress. All right, but continent slamming takes time. So now we've got time, we've got confining pressure, we've got stress, and what comes out is a folded rock. All right, because when you start adding all those things together, rocks no longer act brittly. They start acting like a fluid almost like plastic, like putty. All right, they're going to start being able to act more elastic. All right, so we have several different kinds of folds. All right, I'm going to get to all of them, but first, here are some of the words that I'm going to be using that you should know to help you better understand what I'm saying, and you should probably know it for y'all's quiz and the labs to come. Okay, so short list: hinge line, limbs, axial plane, trace, trend, and plunge. All right, so let's get right into it. All right, so that little bit of jargon I used just a second ago is the anatomy of a fold, essentially. All right, so we have the hinge line. It comes up, goes up over, and it's essentially the crease of the fold. All right, if you were to take a piece of paper and fold it, crease it, that topmost part on the crease is going to be your hinge line. All right, well then on either side of the hinge line we have limbs. So here's a limb and here's a limb. Okay, then our axial trace is going to be a line that represents the halfway mark. All right, where, if there was a plane cutting down, what would that line be? Where would it be? That's going to be your axial trace here. Okay, so we have different kinds of folds, all right, and we define them based on their geometry. All right, so what shape are they? What do they look like? Well, the first one is a monocline. It has one limb. Anticline has two limbs, folds up, it's concave down. A syncline has two limbs, folded down, concave up. So if we were to look at it on this diagram, we have a syncline, which is going to be down, where it's going to be pointed down. All right, and then an anticline, which is going to be pointed up. All right, so we have this where it's folded up, but it's concave down, so it opens down here. The syncline opens up here, and then a monocline is going to look like a ramp, where you just have one limb folded down. All right, but it doesn't fold back over in this area. It just takes that and it just goes down. All right, so do a little bit more specifics. So what to look for a monocline? Well, on a map, it's very simple. All the beds will dip in the same direction. All right, you're not going to see any kind of symmetry. You're just going to see these strike dip symbols all going off in the same direction. Okay, so you can usually expect it to be, if we look at this here, it's going to be associated with a horizontal area. So like here, where we have our horizontal bed, horizontal bed, horizontal bed, but then we have dipping bed, dipping bed, dipping bed, dipping bed, dipping bed. All right, so what's going on here is this is all flat, and then it dips back down. All right, so what does that look like with the rocks? That's what we have here. We've got our horizontal bedding, and then we have a monocline right here. All right, and this line represents the monocline. So if I were to show you this back on the map, you would see strike and dip symbols here. Draw those in. So it'd be strike and dip along here, and then you would see horizontal bedding symbols up here. All right. Next, what to look for in an anticline? Well, on a map, you're going to see the dip reflected and pointed away from each other, and the strata is going to be getting older towards the hinge line. So what does that mean? Well, if we look at our map here, our map quote unquote, we see our hinge line marked in, the axial trace right down the middle, this dotted line, okay? So if we were to look at it, excuse me, if we look at these green beds here, it's dipping off 16 degrees that way, 16 degrees that way, 28 degrees this way, 28 degrees this way. All right. So if we were to take that and look at it in cross section, you're going to see these beds dipping off like so. Okay. And you can see that in the cross section here, where the beds are dipping off in different directions. All right. So now, if we were to take this and apply ages to it, all right, knowing that this is an anticline, we know that the center here is the oldest rock, all right, and then this one is a little bit younger, this one's a little bit younger, and this one's younger too, all right, so it's going to be getting younger outward, all right. So now for synclines, oh, here's another picture of anticlines with the strike and dips marked in. All right, so along this red line is the axial trace, and then the strike and dips are away from the center of that. And since it's an anticline, we know that this center material is older than the stuff out here. All right, now synclines. What to look for? Well, on a map, the dip is going to be reflected and pointed towards each other. All right, so since it's folding into itself, you're going to see the dips folded into themselves. All right, so if I were to go ahead and draw that in, it would look something like that. All right, where you have the strike and dip pointed towards the center. All right, so here would be your axial trace there. All right, so now what's going on with the rocks and their ages is that now they're going to get younger as you go towards the hinge line. All right, so if we say green is our oldest rock, then yellow is younger. Green is the oldest, yellow is younger, brown is young, even younger, younger, youngest. So your youngest rock is going to be in the middle. All right, so here is a syncline where we have strike and dips going in, and here is our axial trace. So that means this is the youngest rock in this area here. All right. Plunge and trend. All right, so we're back to this. So entire fold structures can have stress applied to them to deform them. All right, so if you know, as you tilt a bed, you can tilt a fold. All right, and so when we tilt them, when we rotate them, we call it a plunge. All right, so when you take a fold and you plunge it, it's a plunging fold. All right, and they make these huge V shapes on the map. All right, and you can see them from satellite too. It's really cool. All right, so plunge is to fold as dip is to beds. It's how much this fold was rotated. Okay, and then the trend is going to be the direction or relation to north of a fold. All right, so if you take a plunge, all right, so you know how we take strike and dip, you have a direction that something is going off in and a direction it's tilted. Well, trend is going to be essentially the strike of that fold, okay? So now we're going to plunge and anticline. So first things first, recognize that it's an anticline. All right, the way you recognize that it's an anticline is the same. It's going to be older in the middle, and it's going to dip away from the hinge line in the middle. Okay, but now you can tell the direction of plunge based on the direction that the V opens. All right, so in this case we have an anticline. Anticlines, the V closes in the direction of plunge. All right, so right here, this is our anticline. We have these V shapes like here. All right, that means that it's plunging that way. Okay, it's plunging down in that way. All right, so here we have this V shape. All right, going off like that into that lake, going here. All right, so if we were to go out and take strike and dip measurements, we would see that they are going off that way and that way, and because this V is closing that way, we know it's plunging that way. All right, so what about synclines? Well, synclines, you gotta recognize it's going to dip towards the center, and the strata is going to get younger towards the hinge line. The rocks are getting younger as you go towards the center, and it's going to be the opposite for a syncline when it comes to the V shape. All right, so we have a V here, a V here, and a V here. All right, but this is plunging in the same direction. It's plunging that way. All right, so instead of like an anticline where it's going to close, a syncline is going to open towards the direction of the plunge. All right, and you can see that over here as well, where you have the V and the plunge in that direction. All right, so now what happens if you squeeze it on both sides? So now it gets kind of squirrely, because now we're going to take it and we're going to plunge it on both sides. We're going to squeeze it from two directions. We're going to plunge it fold in two sides. All right, so now you're just going to look for strike and dip symbols, all right, and the age of the rocks. All right, so you're going to have V's on either side. Okay, so thing is though is that those V's can get really close. As they get really close, they'll become more circular. All right, and when they become circular, that's when we start forming what are called domes and basins. All right, so a basin, it's going to be a syncline. You know, it's going to be bowl shaped. It's going to dip in like that all the way around. All right, and it's going to be a syncline that's plunging in all directions, or it appears to be plunging in all directions. All right, same goes for a dome, but opposite. All right, so it's going to be dipping off away from the center, and then your oldest rock is here. All right, but on the basin, the old rock is on the outside. Okay. And here is a satellite image of a dome on the left and a basin on the right. I've already drawn in the strike and dip symbols. Okay, so that covers all of the structures for Lab 9. Hopefully you guys get this in time. Yeah, peace.